Hello, welcome to the Micro 2000 Video Technical Library. My name is Robert McFarlane and I'm the President and CEO of Micro 2000 Incorporated, and I'd like to thank you all for taking the time to familiarise yourself with our products, and we look forward to serving you further in the future.
Hi, I'm Chris Huffman, Vice President of Engineering for Micro 2000, and this tape is going to be about troubleshooting computers. We have specifically rigged some problems with this computer. I didn't actually do the rigging, so I might be as surprised as you to learn what the problems are. However, we're going to use a program to go through and debug all of the problems that exist in the computer. What we're going to start with is ensuring that the computer, whether or not the computer is actually bootable. We're going to use this device, the post probe. So we put the post probe in the computer like this, and then we turn it on. And if the motherboard is functioning properly and all of the cards are functioning properly, at least to the point where it will boot to software, then the post probe will go through all the codes and end up on 00. That would tell me that the motherboard has passed its post test and is attempting to boot to the hard drive. And it is indeed at 00, therefore we know that it's attempting to boot to the hard drive. If we look on the video screen, you'll notice that it says missing operating system. This indicates that there is a problem with the hard drive on this computer. So there's one of the problems with this computer. We'll go ahead and turn the system down and use a software diagnostic microscope to debug the problems on the hard drive. So we place the microscope in the A drive. It is an operating system independent diagnostic, so it will boot the computer to its own operating system. We come up to a loader screen that allows us to either test base memory or load the diagnostic. We're going to load the diagnostic. We're currently waiting for it to load. Now it's loading. At this point, we get our opening screen of our diagnostic, and you'll see that it is showing you which devices it's currently testing to determine what type of devices are indeed in the system. First thing we're going to do is determine, once we get to the opening screen, we're going to hit enter, bring down the system configuration menu. What we want to do is compare the settings first, and what we're looking for is the fixed disk drive. First of all, we notice we did detect one drive, and it's a CMOS type 47, so it's been user defined. And there is one drive in the system, so we know that the amount detected is correct. We hit escape, and we go to the system information. We press enter. The reason we're in here is we want to read the fixed disk information. The fixed disk 0 type is an IDE. It's a Maxtor 7120 AT. The parameters is 762 cylinders, 8 heads, and 38 sectors per track. It's a 15 millisecond drive, and it's showing as a 118 megabyte drive. Now a Maxtor 7120 AT actually has a few more cylinders than that. So what we want to do is hit escape, and we go over to the diagnostic menu. We go down to the fixed disk test, press enter, and on the left of the screen we see a little window appear that shows us what the BIOS on the motherboard believes the drive is. In other words, this is how he's going to treat this drive. 762 cylinders, 8 heads, 38 sectors per track. If we look on the right, we actually see the native parameters from the drive, which is 837 cylinders, 8 heads, and 38 sectors per track. So we automatically know that the CMOS is not set correctly for this system because the BIOS does not know what the drive actually is. Now, it's not only important what the drive truly is, but it's also important to have the drive set up in CMOS identical to the way it is partitioned. So what we'll do is hit escape, We'll go back over to the System Configuration menu, and we go down to the partition tables. We press Enter, and we immediately notice that there's garbage on the screen. You notice it says non-bootable, bootable, non-bootable, non-bootable, ridiculous starting heads, ridiculous starting sectors. They're all different. Starting absolute sectors are ridiculous numbers. The only thing that's valid in here is the 55AA. Now, from experience, I know that this is a virus. However, it may simply be corruption on the boot code. So what we want to do is we'll hit Escape. We'll go over to our Utility menu. We'll go to the Fixed Disk Editor. Press Enter. Bring down our possible drives to edit. We want to edit drive 0 and press Read. This actually allows us to see the information that is in Sector 1 on the drive. And if you can see here, it is a boot code of some type. If we page down, we do see that it is a 55AA. However, this is not a valid boot sector for a hard drive because this information down here starting at offset 100 should all be zeros until the point where we get to 01 Baker Echo, and then that's where your partition table begins. If you notice, there's a lot of code in here. That tells me that this is indeed some kind of a virus. Now, what we need to know is how many sectors per track is this drive truly? That's the first thing we need to know. We know it's currently set for 38, but we need to know if that's correct. So what we'll do is we press F to do a find. We go to hex string, we press Enter, and we're going to search for an F8 because the F8 is what the FAT begins with. So it's set for F8. We tab down, search equals true. We set the starting offset to 0, starting search sector length of 1. We only want to search 1 byte of each sector, starting at offset 0, looking for a FOX8 because we know that the file location table must begin with a FOX8 on a hard drive. So we press Enter, and we immediately notice that we found this on head 1, sector 2. If you notice, the next axis down the bottom says drive 0, cylinder 0, head 1, sector 2. Now, knowing that the partition table exists on head 1, sector 1, the one sector before the FAT, that makes sense because normally the partition table starts on head 1, sector 1, and the FAT will normally start on head 1, sector 2. Now, since this drive is set up as 38 sectors per track, this obviously is correct. 38 sectors per track is the right value. Now that we know that, we're going to hit Escape. We're going to go back over to the diagnostics, press Enter, go back down to the Fixed Disk Test, press Enter. What we want to do is test this value over here, the 837, the number of cylinders, 837, 8 heads, 38 sectors per track. So we go down to a read test. Press Enter. We go to Read Partial. Press Enter. We go to the start cylinder, and we'll say, let's say a starting cylinder of 831. We'll do an end cylinder of 839. Start head of 0 and end head of 7. But actually, let's just read one head to make it simple for ourselves. We'll just read head 0. Hit Enter. We're reading 32. Now, if you notice, we got errors. I'm going to go ahead and turn off this auto mapping here because we didn't stop on the screen. I disable the auto mapping, and I'll try this again. 831. The end head will be 8. The end cylinder will be, let's say, 843. That's fine. Start head of 0 and end head of 0. This way, we're only reading one head of each track. We're just looking for how many total tracks are on this drive at this time. We hit Enter, and as soon as it gets to, if you notice, as soon as it gets to cylinder 837, sector 1, it says sector not found. So we have truly ran out of drive. In other words, this drive is 837 cylinders. It's 0 through 836. That's why as soon as we got to 837, it failed. So we now know that the 837 is a true value for this drive. If we hit escape, we can go back to the partial when we can try another test on the number of heads. We can try 831, end cylinder of 831, start head of 0, and end head of 20. And we start reading again to see how many true heads are on here. And as soon as we get to head 8, it fails. That means that there's only 8 heads, 0 through 7. So now we know that the native values showing under the up in the top left window of 837, 8, and 38 are indeed true parameters for the drive. We hit escape. The next thing to do to this drive is we need to reconfigure the CMOS to set the CMOS to these parameters, 837, 8, and 38. So we're going to hit escape and get out of the program to where we get to reboot. And then when we get the delete message on the screen, we'll press delete and go into our CMOS, go into the standard CMOS. In many cases, you have a user a auto detection for the hard disk, and you can simply do the auto detection. However, remember that you must ensure that the parameter, the partitioning on the drive matches what is in CMOS, or the drive will not work. It's not what the drive truly is that matters, but what it was partitioned to. So this one, we do know that it was partitioned to 38 sectors per track. Therefore, we can also feel pretty sure that the 837 and the 8 will also be valid. We will be verifying that in a moment. So now we're going to write this information. I changed the cylinder count to 837, and we're going to reboot back into the diagnostic. As soon as we booted, now that we've corrected a CMOS problem, now we're going to look for, we have to remove a virus from the partition, and then we're going to have to do some rebuilding of the partition in order to get this drive to function again. These are very common problems with systems, especially with viruses. It seems like everybody, there's a lot of people out there that like to write viruses for some reason. We're not sure why, but I'm not sure they're sure why. Okay, once we're back up, we're going to go back to the system information and just do a quick check. Now, if you notice, the parameters here show 837, 8, and 38, 15 millisecond. It's a 130 megabyte drive. That's what we know this drive is. So now we know that that information is probably correct. And I do indicate probably because we have to, again, if we go down to partition tables and press enter, what we want to do is make sure that the drive is set up to what this partition originally was. Right now it's garbage, but in a minute it won't be. So our next step is we have to clean up this partition information. The first thing we can do is you hit escape. In this particular program, we'll go over to utilities. We'll go down to Rebuild Master Boot. Rebuild Master Boot will simply put a generic boot code on the bootloader. It makes it very simple. You pop up a warning, you press Y to do the write, and then if we go up to the fixed disk editor, we can verify that it now has boot code by rereading drive 0. And if you read it, you'll notice now it says on the right here, invalid partition table, error loading operating system, missing operating system. So now we have some valid boot code. If we page down, you'll notice we still have garbage in here. We want to get rid of this garbage. So we could simply go to M for modify, page down, and zero this out. And just hold on the 0 and allow it to zero out all of this area. Another way to do it would be to go read a sector with all zeros and then write that sector over this sector and then do the rebuild master boot. You can do it either way that you're more comfortable with. I'm doing this just for the purpose of the demonstration, so you know exactly what information to get rid of and what information you want to keep. When I'm done here, The only information that will be left in the lower half of this sector will be 55AA. 55AA is a boot signature, and it must be there in order for the hard drive to be bootable. So now we've cleaned this off. We hit escape, we hit W to write it, we hit Y to say yes and ensure it writes, and then we do a reread of it. Here's the top half, here's the bootloader, we page down, it's all zeros, and there's our 55AA. So now we've cleaned off the virus. It was that simple. However, we now have to rebuild this partition. We have to have certain information regarding the partition. We're going to go back over to system configuration. We're going to go back down to partition tables. Press enter. Now this information looks a little better. They're all non-bootable. The starting heads are all 0, the partition types are unknown, but the boot signature is still there. It's a 55AA. Now, because we zeroed out that bogus information, that incorrect information in here, we need to rebuild proper information. So we're going to press E to edit. Now we know this partition was originally bootable, so we'll say bootable for the first partition. Starting head, we know the starting head is 1 because we found the FAT on sector 2 of head 1. Therefore, the volume would start on sector 1 of head 1, the volume boot sector. Therefore, this is what the master boot record points to, is the volume boot sector. So the volume boot sector is going to be located on head 1. Starting sector will be 1. Starting cylinder is 0. Let's call this partition type. We'll start with, I know it was originally a DOS partition, so we'll say it's a big DOS partition. The ending head, since our number of heads are 8, the ending head would be 7. The ending sector will be 38 because there's 38 sectors per track. The ending cylinder, for now, we'll say it's the whole drive, and we'll say 835 because the way it works is if you have 837 cylinders, you have cylinders 0 through 836, and then DOS does not use the last cylinder of the drive, therefore it's actually 0 through 835 that it uses. That's because the last cylinder of the drive is reserved for diagnostic use. We do test that cylinder. You can test it, but your partitions will never use it. Now start absolute sector. The start absolute sector on the first partition will be equal to the number of sectors per track, which is 38. And the total number of sectors in the partition. The total number of sectors in a partition you calculate based on the heads times the cylinders times the total cylinders in the partition times the total number of sectors in the partition, and that's how you calculate the total number of sectors, which would be 835 times 8 times 38, and then you have to minus the 38 sectors that come right before the partition, if that makes sense. So actually you have 0 through 835 would be 836 cylinders. You have 8 heads and 38 sectors per track, so it's 836 times 8 times 38 minus the start absolute sector, which is 38. Now I'm not sure what that is. I have to calculate it out. For now I'm just going to put in a value of 666666. We'll correct that in a minute. Now that we've put some information in here, especially the pointers to the partition, we can now attempt to access the partition table, the volume boot sector. So we press P for partition. We hit escape out of the edit first. We have to write the information. Press Y to actually implement the write. Then we press P to go to partition 0. We hit enter. We'll also notice that the partition information is all invalid. It doesn't have a valid boot signature. The whole sector has basically been zeroed out. This again is going to have to be repaired. What we can do, since the volume boot sector is missing, we can actually take a volume boot off of a floppy disk and then make some modifications to it. So how we would do that is hit escape. We go over to the utilities menu. We go to the floppy editor, hit enter, do a drive select, and I've put a disk in my A drive, and the disk I've put in is a 1.44. So these parameters over here are correct, 3.5, 1.44. Now I'm going to go to the media select, which is actually valid. and I'll go to accept params. I hit enter, and I hit R for read. This is going to read the volume boot off of this floppy disk. If you notice, it says it's IBM 3.3, and there's a lot of code in here. If I page down, you'll notice it states non-system disk or disk error, replace and strike any key when ready, disk boot failure, so on and so forth. And it does have a 5.5AA. This is a volume boot for a floppy disk. It will work on the hard disk. We will have to make a couple of minor adjustments, but it's basically the volume boots, whether it be on a hard disk or on a floppy disk, are identical in many respects, except for things such as number of tracks and number of sectors. So what we've done is, since it's been read into the floppy editor, we can now go hit escape. We can select the fixed disk editor, hit enter, drive 0, hit enter, and if you notice, it'll state at the top left, current buffer is from floppy disk drive 0, cylinder 0, head 0, sector 1. In other words, it's still got the information from the floppy in the buffer. So now all we have to do is, we know that the volume boot is supposed to start on head 1, sector 1. So we're gonna set the head value to 1 by pressing H for head and typing a 1, hitting enter. And now we're set to cylinder 0, head 1, sector 1 of drive 0 on the hard disk. This is where we want to do the write. So all we have to do is press W for write, press Y, and now we can press a read to actually verify that we did indeed read that, write that to sector 1, head 1. It read fine. If we hit plus and we hit R, we notice that this is the beginning of our FAT. There's the F8 that we found before in the search, so that we know that the volume is now where it's supposed to be. Hit minus and hit read, and there's the volume. Plus and read, there's the F8. Now we're going to do one other thing. We're going to press F for find. We're going to do a search for a hex string. We're going to search for an F8, as it shows up here. Search equals true. We're going to search for starting offset of 0, starting search length of 1. And the reason we're going to do this is because we want to find the second FAT. Now you notice down here on the bottom of the screen, it says the first one was found at drive 0, cylinder 0, head 1, sector 2. Now we need to know how many sectors per FAT do we have. So what we're going to do is press F for find and do search continue. Now you notice it says drive 0, cylinder 0, head 1, sector 10. So that means that there's only sectors 2 through sectors 9 that are valid in this particular FAT. That's very interesting. That's very few sectors per FAT, which would tell me that maybe we have a very small partition on the beginning of this drive. We can verify that by searching for a directory. What we can do is press F for find, go to the hex string search, hit enter. What we're looking for now is the root directory, because I do believe now that since the first FAT starts on sector 2 and ends on sector 9, because we found the second FAT at cylinder 0, head 1, sector 10, that means that there's only 8 sectors per FAT. That means that 8 sectors from now, I'm probably going to find a root directory, and I want to verify that. What I'm going to search for are 6 20s in a row, or actually let's try 5. And this is just a pattern that is always going to be found in directory structures. So not that it can't be found elsewhere, but we'll know a directory structure when we see one. We also need to go down and change the search sector length back to 512 bytes, because we want to search the entire sector. We hit enter again, and notice that we found on drive 0, cylinder 0, head 1, sector 18, we actually found that pattern. Now remember, the second FAT started on sector 10, so if it was 8 sectors per FAT, it would be sector 10 through sector 17. And again, that means right after the second FAT, we have found the pattern of 20s. When I press R to read, you'll notice that I found a root directory. You see IOSys, MS-DOS.sys, CommandCom, and drive space bin. So actually, we have indeed found a small directory on a small partition on this drive. So this partition, we now know that the sectors per FAT are indeed 8. This is the value we're definitely going to need to know to reset back in the partition. So let's go ahead and go reset some of the values to what they should be in the partition. We hit escape. We go back over to the system configuration menu. We go down to partition tables. Press enter. Now currently we have all of our master boot information in here for the ending head and the ending sector, ending cylinder, start absolute sector. Now here is an interesting one. The ending cylinder, that's not going to be valid, but we'll take care of this in a minute. Again, there are multiple partitions on this drive because it's just impossible to think that 7 sectors per FAT can handle a 130 meg drive. It wouldn't be enough sectors per FAT. The reason is you need 2 bytes on large partitions. You need 2 bytes per cluster, and you only have 512 bytes in a sector, and a normal cluster is on a 130 meg drive is probably going to be about 60,000 clusters. So if you did 60,000 clusters and you need 2 bytes per cluster, that means you only have 256 clusters that you can get in each sector. And if you did 256 times 7, you definitely do not have 65 pointers to 65,000 clusters or 60,000 clusters. That would probably exist in a large partition. I may have lost a lot of people there, but bear with me, I'll explain it all as we go. Now, what I'm going to do is press P for partition. I'm going to hit enter. Now, if you notice, we have the volume boot sector that we put from the floppy drive now shows up on this hard drive. The OEM name shows IBM 3.3. The bytes per sector are 512. Sectors per cluster are 1. Reserve sectors are 1. Number of copies of FAT are 2. Maximum root directory entries are 224. Total number of sectors 288. This is all information from the floppy. Now, the boot code for the volume is all valid, but we have to change some of these numbers. So we're going to press E to edit. We're going to hit the right arrow key to go over to here. Bytes per sector, we know that bytes per sector on a hard drive is 512, so that's valid. Sectors per cluster. How many sectors per cluster do we have? Normally, this value on small partitions is going to be about 4 sectors per cluster. On large partitions, it can actually be as much as 64 sectors per cluster. Because we know this is a small partition, we're going to go with 4 sectors per cluster. Number of reserve sectors. Number of reserve sectors means how many sectors come before the FAT on the partition. And since the partition starts at head 1 and the FAT head 1 sector 1 and the FAT starts at head 1 sector 2, there's 1 reserve sector. So that number is valid. How many copies of the FAT? There's always 2 copies of FAT in the DOS world. DOS or Windows NT will always use two copies of the FAT. Maximum root directory entries. On a hard drive, this value is always going to be 512. Total number of sectors in the partition. This number must match this number over here on the left. We know both of them are invalid, so we're going to have to calculate the total number of sectors on this partition ourselves. We'll do that in a moment. The media descriptor byte is currently F0. We want that to be an F8. The media descriptor byte is actually what byte the FAT begins with. On floppy drives, they will begin with like an F9 or an F0 or an F David. On hard drives, the media descriptor byte will always be F8. That's why we're able to search for the F8 on the first byte of a sector to find the FATs. And we did indeed find them. Now, sectors per FAT, remember we already have determined that because the first one starts at sector 2 and ends at sector 9. That means that we have 8 sectors per FAT. So we're going to change that to an 8. Sectors per track. Now this value comes from the same, it should be equal to the same as the ending sector, which is 38. So we're going to set the sectors per track to 38, which is how many sectors per track there are. Number of heads, there's 8 heads on this drive. Number of hidden sectors. The number of hidden sectors is how many sectors come before the partition on this drive. Now the partition starts at head 1, sector 1. We know that, so that means that all of head 0 is hidden on this particular drive. So that means that there is 38 sectors, because there are 38 sectors per track. There's 38 sectors on head 0 that are hidden from the partition. And again, the volume boot sector is 55AA, and that is valid information. So we'll start with, we'll use this as a starting point, and this will help us get a little further. We hit escape to get out of the edit mode, we hit W to write, and we hit Y, and now we've written this information to the partition. We can hit P for partition, we can hit enter to see partition 0, and it's refreshed this entire screen. So now we know that all this information is indeed valid. At this point, we have to do a couple calculations on the drive. What we're going to calculate is we're going to calculate the total number of sectors in this particular partition. Now, how can we do that? Well, one thing we can do is we can go back to the editor, hit escape, go over to utilities, go to the fixed disk editor, hit enter, drive 0, hit enter. Now, what we want to find is we start with cylinder 0, head 0, sector 1. If we page down, we notice that there's a boot signature here, 55AA. It's always the last 2 bytes of a sector. Now, we know there's a small partition on this drive, so there's got to be a larger partition. So what we can search for, we press F for find, we search for a hex string, and we're going to search for a 55AA, and we're going to search, the offset we're going to search is starting at offset 510, because again, offsets start from 0. So we're going to look at offset 510, because offset 510 and 511 will be a 55AA. Because again, if you have 512 bytes and you start at 0, that means your last byte of that sector is byte 511. So we're going to look at byte 510, and we're going to search 2. Our length is going to be 2. And we hope that the last 2 bytes are going to be a 55AA. This will tell us that it's a valid boot. Now, if there is another partition on this drive, we will find the 55AA. We need to find this in order to find the next partition on this drive. So we're going to hit enter. And you notice it's already says down here at the bottom left of the screen, it says search string found, and it was found on sector 1. So we hit find, we hit continue, and now you notice we found it on sector 15. So there's actually a copy of this boot sector, that's what this is in this instance, on sector 15. So we're going to hit find, hit continue, and we found it on head 1, sector 1. Head 1, sector 1 is the partition. If we hit R for read, we see our IBM 3.3, we page down, we see the 55AA, the IBM BIO, disk boot failure messages, the non-system disk messages, so we know this is the volume. We're going to hit find, continue. Now it's going to take a moment because it's actually going to go out and hopefully find the next partition on this drive, providing they do have valid boot sectors, a valid boot sector or valid partition boot, and this will just continue to search through the drive until it finds that string of 55AA in the last 2 bytes of a sector. When the search is done, you'll notice it says search string found. The next access is drive 0, cylinder 33, head 6, sector 15. So we did find a partition on, and we want to write these numbers down. So we have the next partition starts on cylinder 33, head 6, sector 15. Sector 15 is kind of an interesting place to start a partition. Very interesting place. I would have to feel that that's not valid, but let's go ahead and look at it and see. So we hit R for read, and if we notice on cylinder 33, head 6, sector 15, there's actually a boot code. It says invalid partition table, error load in operating system, missing operating system. If we page down, we do see a 55AA. That's very interesting. we're going to go ahead and search and see if there's a volume, because if this was real, then there would be a volume boot somewhere. So we're going to continue and go again and see if we find a volume boot somewhere. Otherwise, this could simply be a backup of a partition or something of that nature. It could actually be a part of a program even. So what it's doing at this point is it's searching the drive for the 55AA, and it will continue searching until it finds the proper string. We're looking for the last 2 bytes of 55AA. Now if you notice, the next one we found was a drive 0, cylinder 68, head 0, sector 1. Now this one sounds more valid than the previous one of cylinder 33, head 6, sector 15. The reason is the main partition or master partition of each partition must be on sector 1 and almost always is on head 0. Again, with the volume being on head 1. So let's read this one and see if he's valid. Now if you notice, we're now reading cylinder 68, head 0, sector 1. There appears to be no information here, but if we page down, you'll notice that you see a 55AA, and remember how I said earlier that at 01 Baker, starting at 01 Baker Echo is where partition information starts. This 00 here indicates it's non-bootable. If it was an 80, it would be bootable. Starting head of 1, starting sector of a 1, this is the starting cylinder number, and it continues on through all this information in hex. So actually we have found the second valid partition on this drive. And the second valid partition, we want to write this down. It starts at cylinder 68, head 0, sector 1. Now if I am correct with this, we'll find a partition probably on cylinder 68, head 1, sector 1. So let's go ahead and do a find and continue. And voila, at cylinder 68, head 1, sector 1, we did indeed find another 55AA. So we're going to read that, and if you notice here, here's a volume boot that states MS-DOS 5.0, no name FAT16. We page down, we see the non-system disk or disk error, the replace and press any key when ready. We see the 55AA, and we have indeed found the second partition on this drive. Further validation of this would be pressing the plus key to go to sector 2, hitting R for read, and you would see the beginning of the FAT, which again, like I said before, always must start with an F8. Now, since we know that the second partition on this drive starts at cylinder 68, head 0, sector 1, that's where we want to point the master boot record to, is cylinder 68, head 0, sector 1. What we need to do now is find out how many sectors per FAT. And remember how we do that? We press F for find, we go to an hex string, and we're going to search, instead for a 55AA, we're going to search for an F8. And we're going to search starting at offset 0, and we know that it must be the very first byte in the partition, and we're only going to want to search 1 byte. So what we're doing is we're now reading, if you notice the bottom of the screen, cylinder 68, head 1, sector 2, which is the beginning of the first FAT. The next F8 we find at offset 0 of a sector will be the second FAT. So we hit enter. Okay, now we found the second FAT at cylinder 68, head 7, sector 1. To verify that, and again, remember, cylinder 68, head 1, sector 2 is the beginning of the first FAT for this partition. So we know the partition begins on cylinder 68, head 0, sector 1. The FAT begins on cylinder 68, head 1, sector 2. And it ends on cylinder 68, head 7. Actually, it would end on head 6, sector 38, because the second FAT is found at cylinder 68, head 7, sector 1. I hope that makes sense. So what we will have to be calculating, we're writing all these numbers down so that we can calculate the exact number of sectors per FAT from these values and the partition sizes from these values. and we will be using this to reset the information in the partition and make this drive bootable again. So I've written down all these numbers, and I believe this is everything we really need from this area. Now we can go back into the partition and start using some of our calculated values. Let's hit escape. We go back over to system configuration. We go to the partition tables. We hit enter. We press. First of all, what we're going to do, this first partition we now know is not the only one on the drive. There are 2 partitions on the drive. So we're going to set partition 1 to the proper information. We press E for edit. We go to partition 1. It was non-bootable because we saw the 00 where the boot signature should be, which is again either a 0 or an 80, indicating non-bootable or bootable. 80 is a bootable, 0 is a non-bootable. Now our starting head will be 0 because we found the next partition, master boot for the next partition at cylinder 68, head 0, sector 1. So the starting head will be 0, the starting sector will be 1, the starting cylinder will be 68. The partition type will go ahead and we'll say this partition type also is a big DOS. This brings up one thing, because this is a small partition, we actually know that this partition is actually like a DOS 16. It's a small type DOS partition. It could even be as low as a DOS 12, since it's such a small partition. But a DOS 16 will work. These values are not that significant. They only tell other programs what kind of operating system it is. So we go back over the big DOS. Our ending head on this partition is going to be 7. Ending sector is always going to be 38. Ending cylinder is going to be, this one is probably going to be 835. This cylinder, we go back over to this one, and the ending cylinder, because the second partition starts at 68, so we know the ending cylinder of this partition is 67. So we type in 67. The start absolute sector. This is the total number of sectors that come before this partition on the drive. Now again, this partition started with, has 38. However, this start absolute sector is going to be quite a bit more. What you do to calculate that is you take the number of cylinders before 68, which is actually 68 cylinders, cylinder 0 through 67, times the number of heads. So you have 67 times the number of heads, which is 8, times the number of sectors per track, which is 38. And if I calculate that on my calculator, I have 67 times 8 times 38 equals 20,368. So the actual starting absolute sector of this partition is going to be 20,368 sectors, because that's how many sectors come before the partition. And again, the partition starts at 0, 1, 68. Now, the total number of sectors in this partition, we again do not know this at this point. We're just going to put a value of a lot of 5s for right now. And then what we're going to do is try to access this partition, because we have pointers to it now, and we can actually pull in some of this other information if there's a valid partition. And we did see a valid partition there. We did see the MS-DOS 5.0 and a valid partition table. So we'll go ahead and we'll try to read in from there, and we can correct these values now that the pointers are correct. So what we do is hit escape from the edit. We hit W to write this information, Y to implement the write. And now what we're going to do is hit P for partition, and we're going to select partition 1 instead of partition 0. We hit enter. And if you notice, we found on partition 1, we found it's non-bootable. Starting head is a 1. Starting sector is a 1. Starting cylinder is actually states it's 34. This is interesting. Partition type is big DOS. Ending head is 15. Ending sector is 38. Ending cylinder is 416. Start absolute sector is 38. Number of sectors is 232, 826. And if you notice over here, there's all garbage. Why is it garbage? Well, the one thing that is incorrect here that I notice is that this says that it starts on cylinder 34. However, we actually found the partition on cylinder 68. Another thing that sounds incorrect about this is that the number of heads shows 15 and our number of heads is set to 8. This would tell me that the initial partitions on this drive were actually using 15 heads, and here's the ending cylinder of this partition, 416, which would actually be 417, 418 cylinders. So the parameters they were using when they first set up this drive in CMOS were 418, 38 sectors per track, and 16 heads instead of 15. Sorry, ending head is 15, so that would mean 16 heads. They did not use the actual valid parameters for the actual parameters that the drive is. They used translation parameters. And since we have found a valid partition, we can believe this information in here and use this to reset up the drive for all of the partitions. And this will actually allow all of our cylinder values to come out correctly. So I'm going to write these down. It's 16 heads, 38 sectors per track, and 418 cylinders. So we're going to go ahead and hit escape. We're going to go ahead and go to reboot, and we're going to reset CMOS one more time to these parameters. Hopefully the screen picks up this okay. And we're going to go to the user define. We're going to set this to 418 cylinders. We're going to set the heads to 16. What they have done is basically doubled the heads and halved the cylinders for this drive. It was not necessary to do that because it's not over 1024, but you never know what to expect when you're running into a system. And again, about 90% of the drive problems we ever see are some kind of partitioning problem. These are extremely serious problems, much beyond what you would normally encounter. So I have the information written in there. I'm going to hit escape. I'm going to go to write CMOS and exit, press Y, and I'm going to reboot the system. Go back in, and now the drive is now set up to 418 cylinders, 16 heads, and 38 sectors per track. And actually, I still have my volume, my disk in there that I pulled a volume boot off of. So I have to load our program. And the computer's rebooting again. Come up to our main screen of the loading. Shows you the load addresses as we're loading. The advantage of this is if this program ever fails, it will tell you exactly where it did fail. And then we also show any of the items that we're currently checking, so that if any of those devices have a failure that would cause us not to function, you can call the tech support and actually tell them exactly where it failed on the screen. So now that we're back up, we're going to just do a quick compare. We go to the system information, hit enter, and we're going to look at what the drive parameters show now. And the parameters for the drive now show 418 cylinders, 16 heads, and 38 sectors per track. And this, I would believe, is what the drive is. So we're getting to the root of the problem. We hit escape, we go back to partition tables, we hit enter. Now we're going to have to change a few values in here. We're going to go press E for edit. We're going to go down to the ending head, which now that we know there's 16 heads, or it was originally partitioned to 16 heads, and all partitions must have the same head value and the same sector value. So we know the head value must be, the ending head will be 15 because it's 15 for the second partition. So we changed the two values on the head to 15. The ending cylinder on this one will still be, actually we found that the other one stated it was at cylinder 34. So I would believe cylinder 33 might now be the appropriate one. Before it was 0 through 67, we found it on 68, but remember we have doubled the heads, so we have the cylinders. So we're actually coming up with 0 through 33, which is a total of 34 cylinders in this partition. But we'll go ahead and put the ending cylinder as 33. And this ending cylinder, I believe from the information we had before, was 416. And we'll verify that again in a moment. This start absolute sector is going to be correct, and we're going to go ahead and write this information. Hit escape, we hit write, we hit yes. Now we're going to check that partition again. Now that we've changed this pointer, we may be able to read the partition correctly. One other value that we have to change is the 68. We saw when we accessed the partition 1 that it said it started on cylinder 34. So we're going to try cylinder 34 there. We hit E for edit. We go down to the 68, we type a 34, hit the down arrow key so we ensure that the 34 does take. Same thing as hitting enter to acknowledge it, and then hit escape. Now we're going to hit W for write, Y so it actually writes it, and then go ahead and hit P for partition. We're going to look back at partition 1 again. Now that we're on partition 1, you'll notice it says non-bootable, starting head 1, starting sector 1, starting cylinder 34, partition type big DOS, ending head 15, ending sector 38, ending cylinder 416. Start absolute sector is 38. Now this is the start absolute sector between this master and this volume. The start absolute sector on the beginning would be how many sectors come before this master. The total number of sectors in this partition we want to write down. That's 232. 826, so 232,826 sectors. The boot signature is a 55AA, and if you notice, now that we've set all these values correctly in the master to point, and we've set the drive to the proper number of cylinders, look at this volume over here. All of a sudden, all the volume information is correct because now we're pointing to the right partition, the right volume boot sector. The bytes per sector say 512, sectors per cluster are 4, reserve sectors 1, copies of FAT 2, maximum root directory is 512. If you notice the total number of sectors, which should always equal the number of sectors over here on the left. So this is 232,826. If you look on the right, this is 232,826. So those are valid. The media descriptor byte is F8, that's valid. The sectors per FAT, we have that value. It's 227 sectors per FAT. Sectors per track are 38, number of heads 16, number of hidden sectors 38, volume boot signature 55AA. These are all correct values, so now I feel very confident that we have pretty much completely restored this drive. Let's hit P for partition. We'll hit the minus key and go back to the master boot record. Hit enter, and we're going to look for a couple other things in here. First of all, we know that the number of sectors in this second partition is now, we're going to hit E for edit, and we're going to go over there. And we know that the number of sectors in the second partition is 232,826 sectors. 232,826 sectors. Because we actually were able to pull that from the partition table that exists out in that partition, which is valid. We also know that all these values are correct. The cylinders of 34, the heads of 15. This is what this drive was originally partitioned to. Now this leads us to one last thing that we have to do to this drive so that we can use the drive completely again, and that is we have to reset the number of sectors on the first partition, and we have to change a couple other values in the first partition. So we're going to hit P for partition. First we'll get out of the edit mode. We hit escape to edit. We're going to make sure that we write this information. So we press W for write, Y. Then we hit P for partition. We're going to go to partition 0. Now, what we have to change here is on the left, we have to change the number of sectors, and on the right, we have to change the total number of sectors. Also on the right, we still have the heads set to 8, so we're going to have to change the heads to a different value, and I believe that's all that we need to do, and then this will be totally correct also. So we hit E for edit, we go to the arrow over to the volume, and we arrow down to the number of heads, and we change that to 16. We can verify everything else just to be sure. Volume boot is 55AA, number of hidden sectors 38, heads 16, sectors per track is 38, sectors per FAT we know was 8 because we found them. F8 is the proper media descriptor. So the last thing I believe, and all the information above I also believe to be correct, especially the sectors per cluster, because again, the sectors per cluster of the second partition was only 4, therefore we would know that the sectors per cluster on this one is probably 4 also, especially since it's smaller than the second partition. So the last value we need to calculate is the total number of sectors in a partition. The way you calculate the total number of sectors in a partition, and I'm going to do this on paper, is you take the total number of cylinders in the partition, and again, the cylinder ends at cylinder 33, so that means there's 34 cylinders in this partition. That's 0 through 33. So there's 34 cylinders, times the number of heads, which is 16, times the number of sectors per track, which is 38, and then you minus the number of hidden sectors. In other words, the number of sectors that come before the partition, the volume boot sector in the partition. So you do cylinders, total number of cylinders in the partition times total number of heads in the partition times total number of sectors per track minus your start absolute sector here, or actually it's better to say the number of hidden sectors, because you want to minus the number of sectors that lie between the master boot record for that partition and the volume boot record for that partition, and you do include the master. Now normally the number of sectors that you're going to minus is all pretty much 99% of the time it will equal the number of sectors per track. So here I'm going to go ahead and do my calculation for this particular drive. It's 34 times 16 times 38 times equals 20,672 minus 38 equals 20,634. And that will be our total number of sectors in this partition, 20,634. And we need to make sure that we set that value both there and in the number of sectors. The number of sectors in the partition table must match the total number of sectors that show in the volume boot sector. So we set that to 0, and then we set 20,634. We hit the down arrow key so it takes, we hit escape, we hit W, and we hit yes to write it. And I believe at this point we have a fully functional drive. All of the information now appears correct. We hit escape. We can do a final diagnostic on it and just go to the diagnostics, go to fixed disk test, hit enter. And if you notice now the native parameters and the BIOS both match. The reason the native keeps changing is because this particular drive is an intelligent drive that will always mimic whatever is in CMOS. However, if you have the cylinder count set too high, in other words, if I had this set to 16 heads, 38 sectors per track, but 1,000 cylinders, he would still only show 418 here because this is his actual total geometry. However, he will mimic the heads and the sectors per track that you set in CMOS, and the cylinders will always be adjusted to account for his total geometry. Now, just to make sure that this drive is fully reading in this sense, we do a butterfly seek. And if you notice on the test, it's working perfectly. So my feeling would be, at this point, we're done. So we hit escape to reboot the system. And if I've done my job properly, then the system will now be able to boot to the hard drive. There are no disks in the floppy drive, so it must boot to the hard drive if possible. And it does say starting MS-DOS. Ask me for my current time and date, and basically I'm now up on a hard drive at a C prompt. So we now know that we've corrected the situation. This concludes this video, which has covered the majority of problems that you'll ever run into on hard drives, and those were drives set incorrectly in CMOS, viruses, especially boot sector viruses, and I showed you how simple it is to remove those from the drives, and incorrect information in the partitioning. And these are what most of our problems that we hear in our tech support line, These are what most of the problems with the hard drives actually occur. And it also seems to be an area of very little understanding. That's why we come out with these videos, to help you, and you may want to review this video several times. So thank you, and we look forward to bringing you more videos of this type in the future.